Welcome to my channel SK Vidyayan Physics classes. Let us discuss some physics questions. First question: radioactive phosphorus with half-life 14 days will be reduced to 3% of its original strength nearly after. Choices are 30 days, 50 days, 70 days, last choice 150 days. The working formula for this problem is n equal to n0 by 2 to the power t upon t half. N represents number of radioactive nucleus present at a time t. N0 represents number of radioactive nucleus at a time t equal to 0, that is initial number of nucleus, and t half is the half-life, t is the time instant. Now since in the question it will reduce to 3%. 3% means 3 by 100. So initial value n0, that is 3n0 by 100, becomes equal to n0 by 2 to the power t by t half. Putting t half equal to 14 days and solving, taking logarithmic and solving, we have t equal to 70 days nearly. So the choice C is correct. Now, a gamma ray photon produces an electron-positron pair, each moving with a kinetic energy of 0.01 million electron volt. The energy of gamma ray photon is, choices are 1.02 million electron volt, 1.04 million electron volt, 2.08 million electron volt, 1.03 million electron volt. What we should do to find out the energy of gamma ray photon, we should take into consideration the rest mass energy of electron and positron both, as well as the total kinetic energy. So when we consider the rest mass energy, electron and positron, they have same rest mass, that is 9 10 to the power minus 31 kg. So the rest mass energy is 2 times m0 c square. So substituting the values for the rest mass of electron and positron, which is 9 10 to the power minus 31 kg, speed of light 3 into 10 to the power 8 meter per second, and converting this into million electron volt by dividing 1.6 10 to the power minus 13, we have, and taking into account the kinetic energy of the two particles, we have energy equal to 1.04 million electron volt. Next question is, when beats are produced by two progressive waves of same amplitude and of nearly same frequency, then the maximum loudness of resulting sound is n times the loudness of each of the component waves. The value of n is, choices are first choice 1, second choice 2, third choice 4, fourth choice 8. We know for if A is the resultant amplitude and if A is the maximum value of the amplitude due to superposition of these two waves producing beats, we have A1, A2 amplitudes of individual waves. So A maximum square equal to A1 square plus A2 square 2A1 A2, and this factor becomes 1 for maximum value. Now we know loudness depends upon intensity of wave, and if I is the maximum intensity of the resulting waves due to superposition, then it is equal to I maximum equal to I1 plus I2 to root under I1 I2. Since amplitudes are equal, it becomes equal to 2y plus 2y 4i, where I is the intensity of each component. So I maximum equal to 4 times I, here n becomes equal to 4. The answer is C, that is 4. Now, the stretched string of a sonometer gives 4 beats with a given tuning curve. A small increase in tension of the string reduces the bit frequency. Consider the options: loading the tuning fork a beat by beat, increasing length of vibrating string, decreasing length of vibrating string. Which of these will help getting unison? Unison means they have equal frequency. First choice 1 only, second choice 2 only, third choice 1 and 2, fourth choice 1 and 3. Now let us analyze. Let NF be the frequency of tuning fork and NS be the frequency of the sonometer wire or sonometer. Now frequency of sonometer is given as n equal to 1 by 12 T by mu root under. Supposing the frequency of sonometer wire be greater than that of the frequency of tuning fork, then if we increase the tension, then frequency of the sonometer wire increases. If earlier the beat frequency was 4, now by increasing the sonometer tension in the sonometer wire, the frequency increases and the beat frequency increases. But it is given in the question that a small increase in tension of the string reduces the beat frequency. So frequency of the sonometer is less than that of tuning fork. So that when we increase the tension, the frequency of sonometer wire increases and the difference, that is beat frequency, decreases. Now we shall discuss about the choices. Now it is given that what we should do so that the frequency should be equal, that is they will be in unison, that is there will be resonance. Now first choice, loading the tuning fork bit by bit. If you load the tuning fork prong, then the frequency decreases. So tuning fork frequency decreases, and if you decrease the length of the vibrating string, then the sonometer frequency increases. So tuning fork frequency decreases and sonometer frequency increases. So it is possible to get unison, that is resonance, that is they can have same frequency. So the answer is 1 and 3. Next question. A radioactive material has a mean life of 1620 years and 520 years for alpha and beta emission respectively. The material decays by simultaneous alpha and beta emission. The time in which 1/4 of the material remains intact is 720 years, 648 years, 450 years and 325 years. Now we know for a compositive process, now here is alpha emission, beta emission takes place simultaneously, and for a compositive process the decay constant should be or is equal to sum of the decay constant for individual processes. That is, if lambda alpha is the decay constant for alpha emission and lambda beta is the decay constant for beta emission, then the effective decay constant is lambda equal to sum of lambda alpha, lambda beta. And if T is the mean life or average life, then 1 by T, 1 by equal to 1 by T alpha, 1 by T beta, that is the mean life is T alpha into T beta by T alpha into T beta. Now T alpha, T betas are given. It is mean life for alpha emission, mean life for beta emission, that is 620 year and 520 year respectively. So substituting the value and simplifying, we have mean life for the compositive process events equal to 325 years. Now the same working formula, that is number of nucleus present after a time t equal to number of nucleus present initially divided by 2 to the power t by t half. Now what is t half? That is the average, that is the half life. T half equal to, we know, 0.693 by decay constant. For the composite process we shall take, that is 0.0693 into 325 years. Now, putting the values here, we know that it is given that it should be reduced to 1/4 of the material remains intact. So n by n0 is equal to 1 by n equal n0 by 4. So this is equal to 1 by 4 equal to 1 by 2 to the power t divided by t to the power t half. Now on simplification we have t equal to t half into 2. So putting the values, we have time equal to 450.45, so nearly 450 years. So the correct choice is C. Next question, a wire having a linear mass density, that is mass per unit length, equal to 5 × 10⁻³ kg per meter, is stretched between two rigid supports with a tension 450 Newton. The wire resonates at a frequency of 420 Hz. The next higher frequency at which the same wire resonates is 490 Hz. The length of the wire is 1.2 meter, 2.1 meter, 5 meter, 5.2 meter. Now, when a stationary wave is formed, transverse stationary wave is formed, now the wire can vibrate in one segment, in two segments, and in multiple segments. As the number of segments increases, the frequency also increases. So, if x is the number of segments in which the string vibrates, the frequency corresponding to that vibration is x by 2L t by mu. Supposing x is equal to 1, n equal to 1 by 2L t by mu root under fundamental mode of vibration. Now, next higher mode, it becomes x plus 1. So frequency in next higher mode is x plus 1, that is the string vibrates in x plus 1 number of segments. So here tension is fixed, mass per unit length is fixed, variable is frequency at which it resonates. So n dash by n dividing, it is x plus 1 by x. Now n dash is 490 Hz, n is 420 Hz, it is 1 by 1 plus 1 by x, that is x plus 1 by x, or simplifying x equal to 6. So substituting the values, n here 420, x 6, you can find out on simplification length of the wire is 2.1 meter. Next question, a solid sphere of copper of radius capital R and a hollow sphere of same material of inner radius small r and outer radius capital R are heated to the same temperature and allowed to cool in the same environment. Hollow sphere will cool faster than solid sphere. It will cool slower than solid sphere. Will cool at the same rate as the solid sphere. Data is insufficient to decide. Now we know the rate of loss of heat proportional to T0 to the power 4 minus T to the power 4. That means T is the temperature of the body and T0 is the temperature of surrounding in which the body is placed. And this term is negative because the heat is lost to the surroundings by the body. Now, we know rate of loss of heat equal to mass into specific heat into rate of change of temperature d theta by dt. So, mass, specific heat, rate of cooling is proportional to T0 minus T to the power 4. Now, in our case, mass of the solid sphere and mass of the hollow sphere are not same, but they are of same material. So because of this mass is hollow sphere is less. Since they are of same material, specific heat is same. Variation of specific heat with temperature is ignored here. Now, d theta by dt, since this is constant, d theta by dt is inversely proportional to mass. Since mass of the hollow sphere is less, d theta by dt is large, that is rate of cooling is large for the hollow sphere. Hence, the hollow sphere will cool faster than the solid sphere. Next question. A charge q is distributed over two concentric hollow spheres of radius small r and capital R greater than small r, such that the surface densities are equal. The potential at the common center is, you have to find out. Now, two spheres, concentric spheres, having that is common center here, radius small r and outer is capital R. Now they are given charges. A charge q is distributed over two concentric hollow spheres of radius r and capital R, such that the surface densities are equal. Now surface densities means charge per unit surface area. Let q1 be the charge on the inner one. So q1 by 4 pi small r square equal to q2 by 4 pi capital R square. This implies that q1 by small r square equal to q2 by capital R square equal to q1 plus q2 by r square plus capital R square. The total charge is capital Q, q by r square plus small r square. From this we can find out the charge q1, that is q equal to r small r square by small r square capital R square. Similarly q2, q capital Q r square by r square plus small r square. Now potential at the center is the sum of potential due to the two spherical surfaces, that is V equal to 1 by 4 pi epsilon 0 q1 by small r plus q2 by capital R. Substituting the values of q, we have potential equal to q into r plus r by 4 pi epsilon 0 small r square plus capital R square. So the correct choice is D, that is q into r plus small r by 4 pi epsilon 0 r square plus small r square. Next question. The fast diffraction minimum due to a single slit is at 30 degree. For a light of wavelength 5000 angstrom, the width of the slit is, we have to find out. It is a simple question, totally based on the formula, that is for fast diffraction minimum d sin theta equal to lambda, n equal to 1 here. So putting the value of lambda and theta is given 30 degree, we can find out the width of the slit as 10 into 10 to the power minus 5 centimeter. Next question is, the binary form of decimal number is 45. The binary form of decimal number 45 is, we have to find out which one is correct. Now the process is, you have to go on dividing 45 by 2 till the quotient is 0, and taking into consideration the remainder, we can find out the corresponding binary number. 45 2 divided, now 22, and this process 22 here 1 is the remainder, again divide 22 by 2 11, remainder is 0, divide by 2, then 5, remainder 1, divide by 2, quotient is 2, remainder 1, divided by 2, quotient is 1, remainder is 0, divided by 2 not possible, so quotient is 0, remainder is 1, and this is the most significant digit and this is the least significant digit. So arranging from the most significant digit towards the least significant digit, we have 1 0 1 1 0 1. So the correct answer is, choice is A. A particle q, a particle of charge q and velocity v passes undeflected through a space with non-zero electric field and magnetic field. The undeflecting conditions will hold if signs of both Q and E are reversed, signs of both Q and B are reversed, both B and E vector are changed in magnitude, keeping the product of B and E fixed. Next choice, both B and E are double in magnitude. How to analyze? Now, a charge moving through a combined effect of electric field and magnetic field passes undeviated means the total force acting on the charge must be zero. That is, force due to electric field and force due to magnetic field, that is Q into V cross B, zero. That is QE equal to minus Q V cross B. Let us analyze. Now it is given, we know that if this is satisfied, then the charge passes undeflected. Now first choice is signs of both Q and E are reversed. If Q sign is reversed, it becomes minus Q. Signs of both Q and E. Now sign of E is reversed. Now here minus Q sign is reversed and B cross B. So this becomes Q. This becomes now QE minus Q V cross B. Now if sign of Q and E are reversed, so this becomes plus Q, and if sign of Q and E are reversed, Q becomes minus Q, E becomes minus E. So here minus Q minus B cross B, so it becomes QE equal to Q V cross B. This shows that the force acting on the charged particle due to electric field and the force acting on the charged particle due to magnetic field are in same direction. So there is no question of getting or passing undeflected. Rather, they will be deflected, that the charge will be deflected in one direction. Similarly, we can analyze by changing the signs of both Q and B. They will be in same side, same sign, so the forces will be in same direction. Q becomes minus Q, B becomes minus B. So same questions. Now it is possible only when B and E are double. If B and E are double here, if B and E are double, magnitude gets double without changing direction, the charge passes undeflected, because 2 taking common, 2 gets cancelled. So QE plus Q V cross B, the condition for the charge to pass undeflected will not be affected. So the correct answer is D, that is both B and E are double in magnitude. Next question. When ultraviolet radiation is incident on a surface, no photoelectrons are emitted. If a second beam causes photoelectrons to be ejected, it may consist of radio waves, infrared rays, visible light rays. Now, of ultraviolet rays and radio waves, infrared rays, visible light rays, these three have higher wavelength or less frequency. If ultraviolet ray cannot produce photoelectrons, then these three, they cannot produce photoelectrons, they cannot cause photoelectric effect. X-rays has frequency much higher than that of ultraviolet rays. Hence, the possible answer is X-ray can produce photoelectrons, because X-ray has frequency 3 into 10 to the power 17 Hz to 5 into 10 to the power 19 Hz. And whereas ultraviolet rays has frequency 8 into 10 to the power 14 Hz to 3 into 10 to the power 17 Hz. So the correct choice is X-ray, that is D. Now next question is, a uniform rope of length 12 meter and mass 6 kg hangs vertically from a rigid support. A block of mass 2 kg is attached to the free end of the rope. A transverse pulse of wavelength 0.06 meter is produced at the lower end of the row. The wavelength of the pulse as it reaches the top is we have to find out. Now, what is the problem? We have a uniform row of length 12 meter and mass 6 kg. The total weight is 6 kg, and here a 2 kg body is attached, and a pulse is produced here. A transverse pulse is produced, and it moves upward. Now, for a velocity of transverse wave in a string, we know V equal to T by mu root under. T is tension, mu is the mass per unit length. This velocity is equal to frequency into wavelength. Now, you analyze this formula, that here frequency remains constant because which is same as the frequency of the source which produces the transverse pulse. So n is constant, and it is given mass per unit length is constant. So tension root under square root of tension is proportional to wavelength. Now tension here is 2 kg or 2 into g, and tension here is 6 kg plus 2 kg total weight, that is 8 kg into g, or simply 8g. So since lambda are proportional to tension, now tension becomes 4 times, means wavelength should become 2 times. Very simple. So 2 times means it is 0.06 meter into 2, that is 0.12 meter. So the correct answer is B, that is 0.12 meter. Now next question is, in the circuit shown, the cell is ideal. That means ideal means no resistance. The coil has an inductance of 4 Henry and 0 resistance. That is, coil is also ideal and will blow when the current through it reaches 5 ampere. Again I am reading the question. In the circuit shown, the cell is ideal. The coil has an inductance of 4 Henry and 0 resistance, and it is connected in series with a fuse, and the fuse will blow when the current through it reaches 5 ampere. Now the switch is closed at a time t equal to 0. The fuse will blow almost at once, after 2 seconds, after 5 seconds, after 10 seconds. Now in the circuit, what is given? A source of EMF and an inductance, ideal inductance, connected in series with a fuse, and this fuse will blow up when the current in the circuit reaches 5 ampere. Now how to solve this problem? Now the crux of the problem is, this formula is very important. Now at any instant, the net EMF or the potential across the inductor, say, is E minus L di by dt. Minus L di by dt is the induced EMF and E is the applied EMF. And applied EMF, the source of EMF, has no internal resistance. Now what happens? The current I in the circuit is equal to net EMF by resistance, and EMF E minus L di by dt equal to I into R. Since R equal to 0, that is resistance associated with the inductor is 0, EMF equal to L di by dt. That means for an ideal inductor, the applied EMF and induced EMF are always equal, and there is flow of current. This is a very important point to understand. Now di equal to E by L into dt. On integrating, I equal to E by L into T, or I is 5 ampere, E is 2 volt, L is 4 Henry. So the current, now I equal 5 ampere, E by L into T. So T equal to 5 into 4 by 2, that is 10 seconds. So after 10 seconds, the current in the circuit attains 5 ampere or becomes 5 ampere and the fuse blows up. Now, very important point is that one should understand the physical significance of this question, that when the if the applied EMF equal to induced EMF, net potential difference across the inductor is zero, but there is current. There are so many situations where the potential difference is zero and there exists current, and this is also one of them. Now, as we close the switch, the current starts to grow and the inductor opposes the variation of current. The process continues. The moment EMF becomes equal to induced EMF, applied EMF becomes equal to induced EMF, the current ceases to increase. Now, that amount of current flows in the circuit at a even though potential difference across the inductor is zero. So, answer is 10 seconds. Thank you. I hope this will be beneficial for the students. Thank you.